This video is for those of you that need a little refresher on some quadratic functions. All right, so your job is you just do the numbered problems and do as much as you need. Then I'm going to link this from YouTube so that there's no Edpuzzle and you can just fast forward to wherever you need assistance, okay? All right, so a function f of x equals ax squared plus bx plus c, where a does not equal 0, is called a quadratic function. Okay, so it does have to have an x squared. The shape is a parabola. Okay, the shape is a parabola, it's a U shape. The maximum or minimum point is called the vertex. And there is this imaginary vertical line that goes through the vertex that's called the axis of symmetry. And it's a line of symmetry that cuts the parabola in half. All right, so if we go back to our parent function, the parent function is f of x equals x squared. So if I plot that 0, 0, notice the symmetry. And we're going to use symmetry as we graph parabolas. And then if you imagine that vertical line. So the vertex of the parent function is 0, 0. The axis of symmetry, make sure you do have that it is an equation, so it's x equals 0. The domain is all real numbers. And the range, though, is y is a real number such that y is greater than or equal to 0. All right, so here are your transformations. You have reflections. That's if there's a negative in front of x squared. Up and down is y equals x squared plus k. You have a vertical stretch or a compression. Left and right is the horizontal translation. All right, so let's just get to work here. In number 1, it says sketch the parent quadratic f of x and the graph of y equals g of x on the same axes. Then write down the coordinates of the vertex and equation for the axis of symmetry for g. So let me change this to dashed here. So my parent graph is the 0, 0, 1, 1, 2, 4. Okay, let's see if that'll do it nice. Oh yeah, look at that. Okay, and then I'll put it back solid and change colors. Okay, so here I can tell the vertex is -3, -2. The axis of symmetry is x equals -3. Then what I like to do is just, pick another point. So if I just randomly select x is -1, plug it in here, okay, plug x is -1 right here, my output is 2. So let's go plot this. If I have -3, -2, and then I have -1, 2, this is opening up, then I can use symmetry to get the other one right there. So that other one would be what? -5, 2, okay? And so what's really neat that you can see here is that this is literally left 3, down 2. If you wanted domain and range, the domain is all real numbers. The range then would be the set of all y such that, and y would be greater than or equal to that minimum point at the vertex. So y is greater than or equal to -2. All right, so then let's come over here, change the pretty colors. Oh, let me do the dashed one. Okay, so, because I think that's fun. Here's 1, 1, 2, 2, 4. Let's make that one dashed. There we go. Isn't that pretty? Super pretty. Okay, and then I will change colors. Okay, so this one has a vertex of 0, 0. So the axis of symmetry is x equals 0. Then let's just pick, if I pick x is 1, y would be -3. And then you can use symmetry to get -1, -3. This one opens down because it's reflected over the x-axis. So then the domain is x is all real numbers, and the range is y is a real number such that, and then I would say y is less than or equal to 0. Okay, hopefully that's bringing that back to you. Translations can be represented by vectors in vector form. If you call it HK, so 0, 2 would be a vertical translation of just up 2. -5, -3 would be left 5 and down 3. When you sketch a parabola, you should include key features, and I actually didn't do my intercepts on the one, so we'll try and grab that here on this one. All right, so here we go. If I want to graph this, and this is standard form, remember you can find the vertex by using x equals -b over 2a, where you have ax squared plus bx plus c. So this would be -7.5 over 2 times -0.5. So that's 7.5. You plug that back in. And again, I am trying to do this rather quickly, so pause it if you need. So then my vertex is 7.5, 10.125. I'm going to change colors. My y-intercept would be 0, -18. I'm going to grab, I went to my graphing calculator, and I just did the x-intercepts from the graphing calculator. So watch what I'm going to do here is I'm going to go by twos. So 2, 4, 6, 8, I'll call this 10, 2, 4, 6, 8, 10. Okay. So then I have the y-intercept, 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's my y-intercept. Then 7.5, that's going to be really close to the 8 and up, just a teeny tiny bit over here. Then I've got my 3, 0, and 12, 0. And then I think this one's at 15, -18. There we go, it's a nice looking graph. And then there's your axis of symmetry. All right, let me double check that I got everything on here. I think I did. Yep, I got it. All right, number 3. To identify the vertex, it's just the opposite of the inside, same as the outside. The axis of symmetry is a vertical line that goes through the vertex, so it's x equals 4. All right, here's all the different forms of a quadratic function. Vertex form, then the vertex is hk. The general form or standard form, the vertex is x equals -b over 2a. And then factored form or intercept form is x minus p times x minus q, where p and q are the x-intercepts. All right, let's look at example, or number 4, sorry, if you need help with this one. Find the vertex, axis of symmetry, y-intercept, then sketch this. So I'm going to use x equals -b over 2a, and then plugging that in, I get y is 5. So my vertex is 3, 5. The y-intercept is 0, -4. the axis of symmetry would be x is 3. All right, so now watch how I'm going to graph this without like making a table. So if I have 3 comma 5, okay, there's 3 comma 5, and then I have 0, negative 4. And, you know, give some ticks here so that we know what we're doing. All right, so if I have my axis of symmetry, then I have another point that is 3 units away, like this, okay? There we go. So then that other point is actually 6, negative 4. And if you wanted to find the x-intercepts, just use your calculator and it'll find it for you. All right, number 5. The coordinates of the find the coordinates of the x-intercepts. Well, remember the x-intercepts are when y is 0. Okay? Now what's interesting is, in case you didn't notice this, if I plot the x-intercepts, remember there's symmetry? So that means the vertex is halfway between. So my vertex is going to occur, what's halfway between 4 and 2? That's going to be x is 3. Then all you do is plug that in. So my vertex is 3, negative 1. Then that makes my axis of symmetry x equals 3. So, and then why don't we get the y-intercept? Yep, it asks for it. The y-intercept is going to be, when you let x be 0, you'd end up with negative 4 times negative 2, which is 8. So then I have a symmetrical point here. There we go. So not bad, not bad. All right, number 6, if you need help with this one, f of x equals x squared plus 6x minus 16, and we want to put it in the intercept form. Well, all that means is factor it. So you're looking for 2 numbers that multiply to negative 16, but add to 6. So I think that's positive 8 and minus 2. That's it. Number 7, rewrite this in the general form or standard form. Well, that just means multiply it out. Well, you cannot multiply 3 things at once, but you can multiply 2 at a time. So I'm going to FOIL that, and I'm going to FOIL it mentally. So that's 2x minus 1x, so that's x minus the 2. And then just distribute the 3. Again, you cannot multiply 3 things at once, but you can do 2 at a time. So you could multiply the 3 times x minus 1 and then take that times x plus 2. And I am doing this rather quickly because this is a review of Algebra 1 and Algebra 2. So this is just if you need a little bit of assistance here, getting this back in your brains. Number 8. Use the information shown in the graph to find an equation for the quadratic function. Write your final answer in the general form. Okay, so let's take a look at this, and we're going to play the what do I know game. I don't think I've mentioned that recently. So what do I know is I have the intercepts, okay? And so I'm going to start with intercept form. And this would be x plus 4, x minus 3. Okay, I'm going to start here. Now, I don't know the a value. I don't know what that coefficient is, like how much of a stretch or a shrink do I have. So now I'm going to use this point right here to help me. I'm going to plug in that this is the x and that's the y. So I'm going to get negative 24 equals a times 0 plus 4 times 0 minus 3. So I'm getting a is 2. So now you have y equals 2 times x plus 4 times x minus 3. Then they want us to multiply that out. And I'm going to kind of let you do that. And you can just check it that you should get y equals 2x squared minus 2x minus 24. If you need help, just make sure you ask me about that one. All right, how about this one? All right, right now I have the vertex. The vertex is 2, negative 2, and I have a point, 0, 4. So I'm going to use vertex form to get me started. So this 0, 4 is the xy. So that's going to be 4 equals a times 0 minus 2 squared minus the 2. If I add 2 to both sides, I would get 6, and then negative 2 squared is 4. So a is 3/2 or 1.5, okay? So now I've got y equals 1.5 times x minus 2 squared minus 2. All right, so this one's going to be a little bit of a challenge here. So maybe try to work ahead of me here. So then you should get y equals 1.5 x squared minus 6x plus 4, okay? All right, number 9, solve the quadratic equation by factoring. All right, I'm really hoping you guys can do these by trial and error. If not, I will show the other way just if you need it, but here's the trial and error. 2x squared, the only way to do that is 2x and x. Now to get a 4, I can do 1 and 4, 4 and 1, and 2 and 2. Well, I know I can't put the 2 in with the 2x because that would indicate there was a GCF across all 3 terms. So I'm only guessing then 1 and 4 and 4 and 1. So when I put 1 and 4, look at my outer and my inner. That's 8x and 1x, so it's a minus and a plus. Okay, so do you see like how fast I did that? If you like the other method, I will go over it. You take what 2 numbers multiply to negative 8, but add up to negative 7. So you are going to get negative 8 and 1. So then that's 2x squared minus 8x plus 1x minus 4. Then you factor by grouping, and you get x minus 4 times 2x plus 1. And then you jump to where I was there, okay? But I'm really, really hoping you guys can do trial and error. All right, number 10, solve by completing the square. All right, first step, move constant to other side. Okay, your first step, move the constant to the other side. The second step, factor out a. So that means pull out the a value. Okay, now we're going to complete the square. All right, so here's what you do. You're going to take half of negative 2, which is negative 1, and square it. So I'm going to add 1. But I actually didn't add 1 to the left side. I've actually added 4. So this is 4 times, and it becomes x minus 1 squared equals 10. And when I divide, I get 5/2. And then watch. You're going to take the plus or minus square root of 5/2. So that's the square root of 5 over the square root of 2. And if we rationalize it, that's 1 plus or minus the square root of 10 over 2. All right, quadratic formula. Now you're going to hear me sing, which is embarrassing because I'm not a good singer, but here we go. If you want to do quadratic formula, maybe you've heard this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so hopefully you'll get that stuck in your head. All right, so here we go. You have to get everything on one side equal to 0. So a is 3, b is 6, c is 2. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So this is x equals negative 6 plus or minus square root 12 over 6. All right, now we do simplify our square roots. So square root of 12 is 2 square root 3. Then I recommend you split these, because then this is negative 1 plus or minus square root 3 over 3. You can't cancel the 6's, okay? You cannot cancel the 6's here. You could factor out a 2 because the numerator has a 2 as a GCF, but you can't cancel those 6's. All right, the solutions of a quadratic equation are also known as roots of the equations. These values are also the zeros of the function. Okay, so roots are the solutions of the equation. The zeros are from the function. P and Q are the x-intercepts on the graph. Okay, so now we have something called the discriminant. And the IB world calls it delta. Okay, this triangle is a Greek letter delta. And it stands for b squared minus 4ac. So, and again, this should be reviewed. I'm just trying to get the cobwebs out for you. If the discriminant is positive, there are two distinct real roots. And you have two x-intercepts. If the discriminant is 0, there's one x-intercept, and sometimes we call it one repeated root or two equal real roots. And if the discriminant is negative, there's no real roots and there's no x-intercepts. All right, so number 12 says find the value of the discriminant for the following quadratic equation and then state the number and nature of the roots. So we're going to do b squared minus 4ac. So it's 5 squared minus 4 times 2 times negative 1. So the discriminant is 33, so there are two real roots. Okay, two real roots. All right, number 13. It says solve the inequality. All right, so when you want to solve a quadratic inequality, you get everything on one side and 0 on the other. So this one, it doesn't factor. It doesn't take too long if you're looking for two numbers that multiply to negative 4 but add to negative 1. You got 4 and 1 and 2 and 2. None of those will work. So it's a nice combo. We need to do our quadratic formula. So it's negative 1 plus or minus square root negative 1 squared minus 4 times 2 times negative 2. This is 1 plus or minus square root 17 over 4. Okay, so I understand that's not pretty. That's not pretty at all. So you could get decimal answers. So if you do the decimals, I got negative 0.78 and 1.28. These are closed circles because it's or equal to. Now, all you have to do is test points. So if I plug 0 in, that's negative. If I plug in a negative 1, that's going to be a positive. And if I plug in, say, 2, that's a positive. So my solution is found right here. I want the positives. So I think they would write the solution like this, that x is a real number such that x is less than or equal to negative 0.78 and x is greater than or equal to 1.28. In interval notation, which I don't think they're going to mark it wrong, we would say negative infinity to negative 0.78 union, whoops, sorry, I meant to make that a bracket. Sorry, I caught it. 1.28 to infinity, okay? All right, then the last one is find the values of k for which y equals x squared plus kx plus 9 has no x-intercepts. All right, so this is an excellent play the what do I know game. If I want no x-intercepts, then I want the discriminant to be negative. Well, b is k, a is 1, and c is 9. So this factors into k plus 6, k minus 6. And then I would test point. I would pick, say, 7. Put 7 in, and that's positive. If I pick 0 in, it's negative. And if I pick, say, negative 7, that's a negative times a negative is positive. So I want values that would be negative, so that's between negative 6 and 6. Okay? There we have it. So if there were any of these that you really struggled with and you actually used my video to fill it out, that means you don't know how to do it. So then pick a practice problem if you see one and try that. I will include the answers here just so that you have them. But make sure that you're actually solving them. So I'm just going to squeeze the answers here.